question 19, we're going to look at what looks a very similar recurrence equation, difference equation. 1.5 is the common ratio, but we're taking from it different differences. When the difference is smaller, we're going to have an increase. The difference balances out. The increase multiply will have a steady state. And of course, when the difference exceeds the multiply, we'll have a decrease. You might actually pay just to generate these three on the calculator itself. Calculator is a very powerful tool. Little word of caution, make sure that you change the function on each occasion. And for C, tick those boxes. And for C, 1.5, Cn, take 22, and they all start from 40. I'll just move that up a little. Have to select all those. In order to generate the graph, we've got to generate the table. So you can see in the first instance an increase. In the case of B, a steady state, a constant 40. So the multiply is balanced out by the difference. And in the third case, the C case there, you can see the difference there exceeds the multiply. We'll produce that on the graph. I may have to do some fiddling around there. But you can see a nice little graph is generated. If you want to analyze this via the graph, go to the trace. Default to the blue one, or my AN. Bounce to the next one, obviously a constant 40. And to the third one, that decrease as the difference exceeds the multiplication of the 1.5. A nice little question. When you display this, you should show it in tables, and if you want to, if you own the book, on the book itself. So for 19A, we could show it like this. And for 19C, B and C, you can see the effects there on the same scale. What you can say is something along the lines of what I was referring to. In the case of A, the initial increase ratio, if you like, exceeds the fixed decrease. So really work left to right. The initial increase, or the common ratio, balances the fixed decrease. So we get that steady state. And finally, the increase R is less than the fixed decrease. So we'll give the three graphs. But particularly powerful use of your graphing calculator there. Very neat there.